Before going to the discussion of the obtained results, let us first demonstrate the operation of the algorithm in a completely autonomous or dead reckoning mode. The slide shows two trajectories. The green one, the result of the EKF algorithm. In red, the trajectory recovered by the developed algorithm. At the start of algorithm operation, the hypotheses about the possible position of the object are distributed over a large area of initial uncertainty. While the vehicle moves and maneuvers, several clusters of possible position of the objects are formed. As the object vehicle moves, makes turns, unlikely hypotheses about position are removed from the set of particles. Only one cluster remains alive. This cluster coincides with the true position of the object. It can be seen that the particles move along the road graph. The particles are weighted proportionally to their distance to the nearest edge of the road. Also, some particles are removed from the set due to their intersection with the geometry of the surrounding buildings. Recall that the trajectory calculated using EKF is shown in green, and the trajectory of the proposed algorithm in red. The developed algorithm works from the beginning in fully autonomous mode without using the data from GNSS receiver. For EKF, GNSS corrections are applied for the first 300 seconds of movement, and then they are disabled. After turning off corrections, it can be noted that the solution of the EKF algorithm begins to float away. We have turned off the graph corrections at 600 seconds. Now the position is only corrected using the building's footprints. Let's see how the filter operates in this case. In parallel, take a note on estimates of the sensor errors. Their true values are shown at the top right corner of the slide. The estimates of the accelerometer and gyroscope biases and the odometer scale factor error are shown in the upper right corner of the video. The algorithm correctly estimated the systematic errors of the sensors. The estimates are very close to the true values. In the case of long motion without corrections, the shape of the particle cloud becomes more and more banana-shaped. This is the expected and correct behavior of the filter. Our object reaches its destination. Okay, let's zoom in the map. We can see that the final estimate is very close to the true one. The positioning error after half an hour of operation in dead reckoning mode does not exceed several meters.